morning, everyone. This panel is on capacity planning. And first and foremost, I wanted to thank Nina Barjison for actually doing all the work behind the scenes to pull it all together. She did the coordination, and Phil Griston from Carradine and also Tim Hu from Wandel were responsible for pulling a lot of this together. So my thanks to them. And there are 4 panelists we have. The format of the panel is we're going to have a quick presentation by Duke Fisher from Verizon, who's going to be first, and then Tom Lundstrom from Quest, who are going to talk to us about how they're using capacity planning in their networks and how they've found value in using planning tools for some of the tasks that they've been working with. And then shortly after that, we'll take questions from the panel, and we also have with us Arman Magbule of Carradine Technologies and Dr. Dave Wang of Wandel, who are the 2 planning tool vendors that are going to be featured in the 2 talks. And we'd love to get audience feedback and inputs on details of how capacity planning is being used. And the purpose, of course, is to provide some examples and best practice knowledge that hopefully people in the audience and those watching remotely can take away in terms of how they want to use capacity planning and planning tools in their own networks. So I'll get started with Duke Fisher.
Thank you, Visha. As he said, I'm Duke Fisher. I work for Verizon. I lead a team of engineers in Verizon that our focus, really truly our passion in the capacity planning umbrella is traffic engineering principles. We use those obviously to capacity plan the networks. Let me start off with some questions for you, for the audience, to kind of answer. You don't have to necessarily answer out loud. But do you care how your networks route traffic? I mean, is that something you actually care about? Is that something that you interact in your job every day? Is performance your customers receives important to you? Do you care what your customers experience when they utilize your network? Are packet drops or high latency acceptable? Then basic fundamentals of network capacity planning affect you. And that's my passion. That's what I do every day in my job. And hopefully me and Tom will just share a little bit about what we do every day and maybe share some ideas back and forth. Now, capacity planning is a huge topic, right? It can go from the individual router on what power it needs, what space it needs, planning the ports, what ports you need, to capacity planning the traffic that goes through the network. Can my trunks handle this traffic? What will happen during a failure? Capacity planning is a huge topic. I'm going to try and narrow it down kind of to what my passion is and what I do, in that the traffic performance on the network. I'm going to kind of just cover 2 things that I know I do in my job every day. Is that we're going to cover basic failure. I mean, everyone has to deal with failure in their network one way or another. And also, what if scenarios. What happens when I change admin cost? What happens if I add a different protocol to my network? So I'm going to go over those briefly. First is the failure scenario. This is common. This is not something new here. We all have to deal with this. What happens when a link or a trunk goes down on my network, or even what happens when an entire router goes down on my network? How does my network react to it? Where does the traffic go? A tool is really necessary, especially in my job, is really necessary to help me figure that out. You can have an outage on the East Coast that's going to affect routing on the West Coast. Now, if you don't have a tool, if you don't have a way to figure out where your traffic flows and what happens to it during that outage, well, you really have only one choice, and that's you have to over-engineer it. You have to, through experience, you kind of get a feel for where your traffic's going, and then you make your best guess. You guess, okay, I'll add capacity here to this link. I'll maybe add another router here, but reality is you really don't know, so you have to spend more money than is really necessary. And that's where a tool, the tool I use is Wandel, and that's where a tool is really going to come into play, because it's going to help you save money because you only put capacity where you need it, when you need it, and not have to over-engineer it. Just a real simple graphic. During stable state, during normal routing times, your traffic right there in the top is going to route where it needs to go, hopefully on its shortest route, hopefully shortest latency. A lot of times latency is always important depending on your traffic mix and what you want to do with it. But what happens when that link goes down? You know, in this simple drawing here, you see it reroutes down through there. Now, all this comes from my tool. My tool, the Wandle tool I use, tells me all this. Without that tool, you can see I got a lot of routers, and I got a lot of trunks up there. And there's no way I'd be able to figure out where that traffic flows if I didn't have that tool. And that's where these tools can really come in good use. And this is my favorite one, is what if scenario. You know, the failure stuff is you know, your day-to-day, your monthly, that's what you have to do. But this is where you really can have fun with your network if you have a tool. If you can dream it, a tool can help you see it. So I'm going to take a quick survey, if y'all don't mind. Who is running MPLS on their network? Okay, oh, a lot more than I expected. Very good. On that MPLS, who's running fast reroute? Okay, very nice. You know, for those that maybe have not ventured into the world of MPLS, mostly maybe because it's just a little bit unknown, a tool can help you understand how MPLS works in your network. So you can load your network into a tool, and you can say, okay, I'm running, say, just ISIS right now, or OSPF. What would happen if I add MPLS? How can I use it? What if I decide with my MPLS to color my trunks, or what's maybe also called admin groups? With the tool, you can do all these what-if scenarios in an ISAFE environment, and it'll accurately predict what will happen to your network. One thing a tool is really good at, it's going to take into account the type of routers you have, your router vendor. It's going to take into account what protocols you're running, OSPF, ISIS, BGP. It's going to take into fact if you're utilizing traffic engineering extensions, such as bandwidth-aware LSPs. It's going to take all those into account and accurately predict what will happen to your traffic, where it's going to flow. And so it creates a sandbox scenario. It can be actually kind of fun to play with. Let me give you an example of a what-if scenario I'm actually doing right now in Verizon. We have two networks, if you will. One's a big network. Both are global. Big network has a large, the first network, Network A, is a large network, 900 routers. It's global, really big. Network B is also global, but it's a smaller, has less number of routers, but it has big trunks. Right, talking, you know, 10 gig and 40 OC768, and actually we just added 100 giggies in Europe on it. The goal is we're going to IGP merge these. They're running two different IGPs right now. They're both running OSPF. Let me go ahead and flip. So the bottom network, Network A, is the big network, 900 routers, global, really big. It's running an OSPF. Now its OSPF cost scheme is based on based on airline miles. So when we assign OSPF cost to a particular link, we're just using the airline miles distance to determine that. Network B, however, its OSPF cost scheme is based on route miles or latency, to be exact. When we turn up a trunk, we understand the exact latency that it has, and we set the OSPF accordingly. Well, we want to IGP merge these two. So combine together the layer 3, right? So they have one OSPF. The problem is, if network A is airline miles based, its OSPF cost is going to be inherently lower than network B. Now the problem is network B is the one that has all the big trunks, and it actually already has its own traffic on it. If we were to just IGP merge these together without doing anything, most of the traffic from network B is going to go down into network A, which is the exact opposite of what we want going to happen. If that would happen, we're going to blow network A out. Trunks are going to blow up. So we use the tool over many, many models to change our OSPF costs on network A to be latency based also. We're talking, you know, 250, 300 trunks that we have to change the OSPF cost on. It's huge. There's no way we could do it without the tool. But I'm sitting here in my what if scenario, and I can change my OSPF cost. The tool is going to tell me where my traffic's routing, what the latency is, if there's any changes that I like or don't like, and then I can tweak the OSPF cost to make it go where I want to go. So that's a what-if example. Hopefully I didn't take up too much time. Tom's going to come up next, and then we'll answer questions afterwards. Tom?
Do we want to take any questions on the immediate talk right now? Or?
We'll let Tom go first.
Okay, let's do that. So I'll bring up next Tom Lundstrom of Quest, and then right after that we'll take questions for both Tom and.
Sorry.
No, perfect.
Well, good morning, everyone. My name is Tom Lundstrom. I'm with Quest. Some folks might be aware that Quest was recently acquired by CenturyLink. Our headquarters have moved from Denver to Monroe, Louisiana, and we'll have an official name change campaign in the August timeframe to change the name. So the talk today is on capacity planning, and my hope is to give you a feel for some of the things that we're doing at a service provider level. By way of introduction, I wanted to share with you two slides. The first is an overview of who Quest is, if you're not familiar with Quest. Our infrastructure includes a large fiber backbone. We have all the services that you might expect. We have 15 million access lines and 5 million broadband customers. So I did a check a few days ago, and we have about 13,000 routers that I was able to locate in a database that we have. The part of that, that consists of a Metro Ethernet, a broadband network, VPN, a bunch of voice stuff that we're doing. The part of the network that I am a member of a team that manages is the IP backbone. And we're present in 60 cities. We have about 120 core routers, 630 edge-facing routers. And so there's about 1,000 routers in that network that we help manage. And our link sizes are in the range of 40 gig to 120 gig in size. So that gives you a feel for some of the work that we do. So my second slide is extremely fascinating, but I wanted to kind of give a feel for the perspective from which I'll be talking today. So planning can be handled probably in this audience in various groups. For some, it's a finance or a budgeting exercise. For others, it might be a function that's performed in a NOC. And for others, you may have a department that handles capacity planning. At Quest, we have a department, as you might expect, and I'm a member of that department. We have both a 1 to 2 year tactical interest as well as a 3 to 5 year strategic concern. So I'll get into it a little bit deeper here now. So our team's mission, some of the goals that we shoot for. Number one, we try and route every packet along the lowest latency path during healthy state. Number two, we've been asked to try and survive any failure, and we look at about 500 of those with no congestion. And then number three, we've been asked to meet all of our customer service level agreements. So that's pretty obvious, and the last thing we've been tasked with is to do all this good stuff at the lowest cost. So this next set of slides gets into some of the planning structures and tools that we have in place. And this slide here, I'll present 3 layers of tools. This is our data layer. We use 2 open source databases, PSQL, Postgres. It's designed to handle daily snapshots of infrastructure. For example, lists of routers, list of interfaces, IGP adjacencies, BGP session information, stuff like that. The second open source database is round-robin database, and it's designed to handle the 5-minute data, so CPU utilization, traffic stats on interfaces and LSPs, stuff like that. Obviously, from our perspective, we have an interest in the traffic component of our RRD database. So our second layer here is our toolkit, and we have an in-house forecasting process that's developed over time. We have a homegrown simulation engine, and we have a set of Python utilities that we use. The other half of our toolkit then is vendor purchased, and we use Keratin's Mate product, which consists of 3 components. There's an archive, which takes a snapshot of the network every 2 hours. There's a simulation engine, and a GUI that helps us visualize what's happening in the network. So you'll notice a component here that's homegrown that I added to the vendor side of the equation. Excuse me, the problem with purchasing from a vendor is that you get yourself into this situation. The scenario goes like this: you purchase the product, and with a short amount of time you realize that the product that was purchased doesn't exactly meet what you intend to do. So Keratin's developed this function called an add-on, and that allows us to essentially use the toolkit for what it was intended to do, and augment it with Perl and Python scripts, simple Perl and Python scripts, for those cases that we need to add further development to the tool. So if everything works right, if our data is right and our tools are good, then that informs our third layer, which is the people layer, folks in our planning, and to some extent our operations groups. So that was kind of a high-level summary of some of the databases and tools that we use. This next section here talks about some of the specific components that are required to simulate, to take a live network and put it in an offline or a simulation type environment. And it's really everything that you would expect. You need a list of routers, you need a list of circuits with capacities and metrics, you need a sense for traffic that'll be on the network in the future, and you need to have a list of SLRGs. And just a quick refresher on SLRGs. SLRGs are shared risk link groups. They're a set of circuits that share a common physical vulnerability. For example, a set of circuits that are provisioned through a particular conduit. When that conduit gets backhoed, that set of circuits goes down. Or the set of circuits that are provisioned to a router, that router goes belly up, and that set of circuits goes down. Here's a few that get our blood pressure up. This is a train derailment that happened about 60 or 70 miles west of here, over Berthoud Pass. My understanding is that from this experience is that train derailments that happen inside of tunnels are especially difficult and lengthy to clean up. This is Hurricane Allison. That's not the floor, that's actually a stream that's flowing through there. And this is a wildfire here not too long ago in Texas that took the roof off of one of our repeater sites. Thus, we lost a set of circuits that ran through there. So we talked a little bit about the components that are required to set up the model. One component that's especially important is the demand forecasting. And I think demand forecasting is a talk all in itself. But I did want to mention a couple things in that. At Quest, we deploy several layers of full MPLS meshes, which makes measuring historic traffic flow rather easy. We have an explicit set of data that tells us the distribution of traffic across the backbone. So the other important component here is this idea of tuning. So the idea is that it's fairly easy to get a sense of what traffic is flowing across your network at a network level. But it's really important to drill down into that a little bit and make sure that the network story or the growth story makes sense at other levels too. For example, how much a particular site might be offering to the backbone or taking off the backbone, what services are growing within a site, and you can get further on down than that. So we've developed a set of tools that help us visualize and ensure that the forecast is right on, spot on. Okay, so we've got the model set up, we've got the forecast to where we're comfortable with it. The next step is modeling. And that's a process of examining the SLRGs that we've set up. We do that exhaustively. And the idea is to take your set of links and determine the worst possible thing that can happen on each link. And part of what comes out of that then is what you'd expect. We get a list of circuit augmentations that need to happen, and we get a list of, or a sense of costs for that. And we also know then what hardware platforms will exhaust and approximately when to drive next generation core upgrades and things like that. Okay, so that's sort of the structure. The next set of slides, I hope to transmit a sense of some of the studies that we work on throughout a typical year. And I've put these into three groups. The first bullet here is our core competency, or our core responsibilities. We have an annual planning cycle, comes up with a list of circuits that we need to add, and we update that quarterly, sometimes more often if we think we need to. The second bullet, occasionally, because of the tools that we have, we get involved with our peers in operations and look at some reason for outage type studies. And the third group, though, I think is really what I find very interesting, and I'm going to drill into these a little bit further. I've listed 4, but I'm actually going to only drill into the first 2. So we did this study recently where we took a group of network topologies that looked interesting and looked like they might be something that would help us out. And then we looked at a set of IGP metric schemes that looked like they held some promise. And when we combined those together, we had a set of combination of different things that we looked at. And the chart here that you're looking at, the y-axis is cost, and the x-axis is average latency. So as you go up, you get more expensive, and then as you go to the right, your network becomes slower. Average latency increases. And what we found is what you'd expect. There's a set of schemes that produce very fast networks, but they're also very expensive. Those are on the top left, and then on the bottom right, we have a group of networks that are cost efficient, but they're extremely slow. So the cool thing about this study was that we found a combination, and we built ourselves a narrative of what really fast but really cost-effective networks look like. And we use those for guiding then future planning cycles. So we thought that was kind of fun. The second study that I want to drill into a little bit is this concept of fan-out, and that is actually something that we discovered here at NANOG a few times back. So the idea behind this chart is that on the x-axis we have a 24-hour period. And what we've graphed here is a single flow from one interface out to some point in our network. And the solid line represents the usual traffic flow that you see. You have the nighttime valley and the daytime peak, and that's all fine and well and expected. But the really neat thing is that if you look at the dashed line, that represents the percentage of the total traffic on the link that this flow represents. And it's really common for us to see that percentage be very consistent. In this case, that percentage is right around 30 to 40%. It hangs in the 35% range. And that's kind of neat, and we think it's useful in the planning process. So I won't get into that much further. I have 2 more slides. Evolution is the topic. I think when we first started this challenge 6 or 7 or 8 or 9 years ago, we found that we had a boatload of really good information. But the problem was trying to get something useful out of that. And I think 3 things really contributed to that. We found ourselves with a pretty diverse skill set. We've got some folks in our operations group who know how to store the data and make it easy to access. And then we've got a couple people who know how to mine it out of there. We were able to steal somebody from our operations group who keeps us kind of grounded in things that are practical and keeps us out of typical planning areas that tend towards the crazy side. We've got a couple mathematicians and a programmer that helps us solve some of the really hard problems. And then we've got a couple of folks that have stepped up to the modeling exercise and have become kind of experts in working with the vendor tools. Second bullet, we have a good relationship with our vendor to help explore some new and different areas. And then the last bullet is this concept of repetition. So you do a study, and then you validate it, and then you might build a tool, and then you start again and you do another study and you validate it, and you might improve your tools. And I think that process over years' time has really helped us produce what we think is some good work. So the final part of our evolution story might be sort of getting out of the pure capacity planning role and beginning to offer insights to the business, and on a good day even informing decisions and influencing, or at least informing strategy and policy. So thank you very much, and I think we'll hand it off to you, Vishal. Here now.
So thanks, Tom and Duke. So right now what we'd like to do is open it up to the audience for questions, and they can be generic on aspects of the presentation that you might want more clarification on, or related more generally to the planning process. And then the questions can be to specific panelists or just to the panel as a whole, and then we'll try and take as many of those as we can. So I'd of course like to open it up to the house and see if there's any questions coming from there. Otherwise, there might be some things that I've made note of.
Glenn Reynolds of MediaCom. Duke, when you did your background into that for the links and them going down, did you also take into consideration the cellular backhaul that's being done through most of the cable companies now?
Is this on?
Yeah.
Cellular backhaul. I'm not differentiating between traffic types. Are you asking about traffic types going across the network, or are you asking about the access into the network?
Well, when you were talking about a link failing and the switching over, did you also take into consideration the backhaul part of it that may fail, forcing a link within a different company, like Comcast or MediaCom?
Yeah. So I'm lucky in that I own the fiber that I'm on. I'm Verizon, so I have a large fiber backbone. But what you're getting at is what Tom was sharing, shared risk link groups. You've got to know, obviously, where your trunks or links, I don't know what you call them, where they route, on what carrier, and in particular, where their vulnerabilities are. So if you have your trunks going across different carriers, one's by Comcast, another by another carrier, can you know where those single points of failures are? And so then what you do is you take those and you can put those into the model, and you say, okay, this single point goes down. Say it's a splice point, or a railway taking out a whole tunnel. How many trunks are going to go down? So you tell the model, okay, trunk 1, 2, and 3 are going to go down, and then the model will then tell you, okay, all that traffic that was going through trunks 1, 2, 3 are going to redivert to these areas here. Is that the question you're asking?
Well, yeah, the reason I was asking that is, we've just signed contracts with Verizon to backhaul over 300 towers, as well as with US Cellular and Quest to backhaul another 300 towers. And, if your model has some flaws in that, I'd like to look at Wandel a little closer for our operations group, since I'm the senior manager there. But I just wondered if those were also taken into consideration.
Yeah, absolutely. Trash in, trash out. That's where you've got to hit up Verizon and US West and say, where are you routing this? And then you can plug that into the model. And that's what's great about the model, is it's totally flexible. So you can go into the model. In Wandel, it's called a facility file. I don't know what it's called in Carradine, but and you tell that facility file, for this failure analysis, I want trunks 1, 5, 6, 8 to all go down, because I know that Verizon and US West are sharing a fiber conduit there, and that's a single point of failure. So that's what's great about the tools, is they're very flexible.
Thank you.
Yes, sir.
Yeah, sure, Arman.
So what you said is absolutely correct. What we're finding is that
This mic, is it on?
well, thank you. Duke's perspective is what we find elsewhere too, is that the core backbone group tends to be service agnostic. So within Verizon, within most of the telcos, there's a IP backbone group that's service agnostic, and then there are service groups that are aware of very specific mobile backhaul sales that they have made. And the planning takes place in both of those. The failure planning takes place in both of those groups. So somebody like Duke and Tom make sure that as far as aggregate traffic is concerned, your traffic is safe. There's yet another group, because your mobile backhaul often will go through an edge network or a regional network that is outside of the main AS, possibly goes through that AS, then goes out to another edge network. And for your service to be well planned and assured, there's another group whom we usually help that has to have a view of the edge networks, a view where your service is actually defined, and help from the backbone. And it's those folks who will say, one of those 300 may be in trouble or not. And that division tends to work pretty well, and you have to have that. The backbone folks really cannot keep track of the millions and millions of services that exist, and then the service folks really cannot be keeping track of the backbone on a day-to-day basis.
So does that answer the question? So just to summarize, I think what Arman said is there's two different groups that are handling it, and a group that's offering the services would have a view of specifically the backhaul. And I think what Duke and Tom said was that when you're talking to the operators you're buying capacity from, you need some knowledge about what they're doing with the traffic that you can then plug into hopefully your planning tool and get a sense independently of what the operators might tell you about what's going to happen should something fail. So that both of those will together provide the kind of security I guess you're looking at in terms of the backhaul traffic. Right? So other questions from the audience?
So
Okay.
I have a question for the audience. Of those of you out there that, I don't know who would do something like this in capacity planning. For those of you out, do you currently use a tool?
Actually, that's a good one. So how many people are actually using a planning tool? Of the people who said they have MPLS networks, how many are actually using formalized planning tools for their planning process? 1, 2, 3. That seems like, I would say it's like
And
less than 10%.
Yeah, and so my next question is, for those of you that are in charge of capacity planning and don't have a tool, are you just over-engineering it, spending more money than you need to, or have you done an in-house tool? Excel. And I'm glad you said that, because Excel spreadsheets, right? It's insane. It's absolutely insane. That's one of the things I absolutely love about a tool is I load it in there and I have a graphical display in my network. I'm a visual. I think visually. And so with the tool, you visually see where the network's going, where it's routing, where the outages are. I really encourage it just because your return on investment, you'll have your return on investment in less than a year because you won't have to put capacity in where you don't need it. You can only target exactly where you need it when you need it. So yeah, get off those Excel spreadsheets. They're insane.
So I think initially about 30 people said they're doing IP/MPLS planning, and maybe 3 or 4 said they actually use the tool. So how many? I don't know how many people feel they have a network, I guess, big enough that could derive value from having a tool. Of course, if you have a small network, even in fairly small networks, there's a lot of value that you could derive, in my opinion. But how many people who are here would feel that perhaps a tool would benefit them? Would you mind raising your hand? That's 1, 2, 3, 4, 5. Yeah. So about 10% of the room feels that they could perhaps immediately use the tool. And I think the important point here is Excel spreadsheets are great when you're doing sort of just basic capacity planning. But if you want to do what if scenario planning, it's just very difficult, I believe, to do with in an Excel spreadsheet and visualization. And I think Dave and Arman can probably comment on that as what they're seeing as a value that sort of your customers are deriving from the use of the tool. If you have some comments or something that you might want to illuminate the audience about, I think that'll be valuable at this point.
Yeah, on the on the Wando side, the tool on one side is for your existing network that you can simulate if you have a set of nodes, links, the topologies, and traffic matrix. And then you can simulate with or without all kinds of the, say with traffic engineering, without traffic engineering. So you can do a lot of what if at the, at the network, existing network level. But on the other hand, the tool is actually also useful in many the so-called difficult computing cases. For example, if you if you currently have 1 terabit of traffic every second, then for the next 5 years you expect it to go to 10 terabits or 20 terabits. What kind of network are you getting into? The tool can be used for this kind of computing. We can configure either 10 gig links, 40 gig links, 100 gig links. And in a matter of seconds, you see many, many, many different topologies and different costs. So the data is can be easily created for a lot of what-if analysis for the future, or if you change OSPF to ISS, or if you get into cloud computing, you get into layer 2 computation, you have to discover all your layer 2 topologies. All this kind of thing is actually part of the tool. Occasionally they'll be very useful, but most of the time it all depends on your problem, your questions. Thank you.
So I'd say this is one area where Carrot and Wandel differ a bit. The visualization is extremely important, but what we're finding is that there are a set of tasks that just need to be automated and done over and over again. And that's the sort of things that Tom was mentioning with the add-on. We're finding that there is a place for doing what-if analysis, but there's also a big place for automating process or at least streamlining them. We're finding, for example, that a lot of sales folks tend to come to the network engineers asking about a particular big customer. If I were to add this customer, would they be accepted? And it's taking up very valuable time of valuable engineers' time for doing these sorts of things. That process could be and should be automated such that a tool can do that for you. We're finding that a lot of customers prefer to have a baseline planning done automatically for them, just so that doing something that's very simple, just increasing it based on the failure analysis, increasing it based on set amounts, so that every week, every month, you can have an automated report that goes to your CFO that says, look, this is the worst it could be. And then you can be doing the what-if analysis on top of that. And I think that's important, both the visualization and the automation aspects.
Absolutely. So does that trigger off any thoughts from the audience? Yes, please.
Yeah, I have one question. My name is Paul Mendel. I'm with Google, but in Europe.
Sorry, could you introduce yourself again,
yes,
please? We didn't
Paul
get that.
Mendel with Google, but I'm based in Europe. So I have one question with regards to these what-if scenarios. Do you also look into when and where could it make sense to establish local peering connections, or even to foster some local exchange point? Is this also something which is being looked into? For example, in Denver, I understand there is no exchange point. Traffic is going back and forth to whatever, Atlanta or whatever. I don't know exactly how it works in the US.
You have a good example?
Yeah, we have done this peering analysis, exactly what you're talking about for Yahoo. Actually, Yahoo is using our tool for exactly this purpose.
Yeah, I think from Quest perspective, is this microphone on here?
Yeah, it's on.
Yes.
Just want to pull it a little bit closer.
That's actually a really important component of what we do, is to try and not only understand traffic flow, but to understand those components that add cost to the network. And sometimes things that are growing really rapidly don't actually add cost to the network, and it's important to differentiate those. And I think the area that you bring up is one of those. So.
And Tom, yesterday in the discussion you were talking about also computing what volume of traffic is moving in and out of the network. So presumably that would give insights into where peering might make sense, or what volumes of traffic would be required to be peered.
Yeah, so I think what Vishal is referring to here is this concept of getting a sense for not only what happens inside of your network, but traffic flow across the network. And I think there's a lot of development work that's happening in that space right now. And it's probably one of the areas that we'll see grow in the next few years.
And then, Tom, we were talking yesterday how, doing what-if scenarios changed a metric within your network, and it caused the traffic coming in from one peer to then now go through a different peer.
Right.
Because, the advertised routes on one peer, was when you changed the metric, then they came from the advertised routes from a different peer.
Yeah.
And depending on what your contracts with that peering is, that could have cost you, some serious money. So that's where definitely I think that what-if would help and benefit a lot. Does that answer your question? Yes.
All right, so other questions from the audience? So Tom, just want to go back to something that you said in your presentation, which was that you needed to do some add-on software.
Right.
So one of the things that would be worth maybe highlighting here is kind of what kind of additions were needed and what kind of effort was involved, because some people in the audience may think, well, Quest has the resources to have this kind of add-on software done. Do we have it? So perhaps you can allude and address some of those concerns.
So maybe, so the question is about augmenting the tools. And maybe I'll just give you a sense of what we do. We developed some add-on functionality that allows us to essentially forklift the IGP metrics out of the model and replace them with a new set. And that's something that could be done outside of the modeling process. But it's really nice for our modelers to be able to just point and click and do that inside the GUI. And what that took was it might have been 3 or 4 or 5 pages of a Perl script. It works in conjunction with the tool and just makes that process easier. Another example might be some evaluation add-ons that we've added to the tool. It gives us the ability to take the worst case, get a list of circuits, and then maybe apply some cost to it in a way that we feel is right for whatever study we're doing. So just a couple of examples.
Wonderful.
I'd like to say the second add-on Tom said is the most popular add-on. Everyone seems to have a different notion of what their cost structure is. And route miles, what discount they're getting from a particular vendor. And that by far seems to be the most popular add-on.
Any other thoughts from the audience?
Well, I have to say that most of the customers' data conversion into the 102 is totally automated. So that's the thing that we are driving into, because we basically, at the beginning, we are the planning tool, but then we found that more and more people put a lot of effort into creating the file we need. So we automate that by simply reading config files directly from Cisco, Juniper, Actel, Lucent, Huawei. So we process config file, and then for the 5-minute traffic, we automatically collect traffic of every 5 minutes from the entire network. And if you have your own round-robin database, we convert it into our format. So the challenge on the tool vendor side is simply automation. We try to automate the network design planning process as much as possible.
All right. Other thoughts? So just want to go back to both you and Tom, Duke, and you in terms of maybe you can illuminate a little bit about, you talked about what kind of insights you've been able to derive. So there are 2 parts to it. One is, of course, you just do basic engineering, planning, and architecture, and that's already providing value in terms of cutting down time or the various scenarios one can visualize. But then the next step of that evolution is what you said, it began to influence sort of business insights. So I'm wondering to whatever extent you can, if you can give some sense to the audience of what kind of business insights were valuable and how they might have informed sort of more important economic decisions in strategy.
I can take that one. So the idea is, what do we provide in addition to kind of the capacity planning area? And I think we touched on this a little bit from one of the last questions here. And Really, I think a big area that we've been able to help out with is this concept of, things are definitely growing on the network, but not everything that grows has a cost associated with it. There's things like non-concurrent peak hours that are very difficult to examine outside of a model type environment. And insights like that, I think, have proven helpful in making the right business type decisions.
So for example, making capacity at non-concurrent times available for other services and things of that sort.
That's right.
Which you wouldn't have known about or wouldn't have thought about had you not done that level of intelligence. Okay, wonderful. Any thoughts from, I don't know if the planning tool folks have any examples or thoughts on this, how your customers have used the tool not only just for basic planning, but then to take it to the next level in terms of deriving insights that actually help in the business as well.
Well, most of the insights can be derived from several kind of questions. Actually, Tom mentioned, like if you have 3-year planning, 5-year planning. So if you, those planning generally, the topology can be quickly constructed to give you some idea the traffic you are going to handle 5 years from today. And then you can translate that. For example, if you already have 210 gig pipes, and 5 years from now, you imagine 10 times more capacity, then you need about 2,010 gigs. Then it drives you into some financial computation that do you need to keep leasing wavelengths or lambdas or from Quest or from level 3, or you want to buy some fiber directly, or you want to build something else. So this kind of thing can be easily exercised if the tool can help you construct the entire network for whatever year you are looking for. So we actually have a couple of customers. Every time they do a 2.5-year planning, they end up with a lot of proposal trying to buy or lease or all kinds of fiber acquisition plan. And at the end, due to their financial structure, they discard this kind of proposal. They say, okay, this is not for us, so they will keep leasing. So it will give you this kind of decision.
What we're finding is that visibility is awfully low. So the lack of information about how much traffic goes from one end of the network to the other end, or how much of a customer's traffic goes, is extremely low. And the sort of automation of discovery and automation of traffic that Dave was talking about, we find that having that storehouse of information available ends up being incredibly useful for all sorts of things that you just would not have thought about. Tom mentioned one, cost analysis, per customer cost analysis is quite important. Sometimes it is actually just better to get out of some markets.
Absolutely.
You need to know what your cost structure is. And to do that, and for a lot of other business decisions, you need to know how much traffic is going from where to where in your network. And that storehouse of information, I think, is actually crucial for all of the business operations.
In fact, what you just said, Arman, the storehouse of information, also the storehouse over time. So you have a history. So as you just mentioned, if you're seeing consistently that something is costing you more or the cost is going up over time, then as you said, you might actually want to pull out of that market and move to a different market or have a different way of offering that kind of service. Is that something that, Quest and Verizon have experienced or made use of at all in the work that you've done?
Yeah, we hit a lot of topics there. Like building on, you got to collect the information. Whether it be net flow information, IPFix, CFlow, depending on what vendor you're using, and taking all of that. And there's open source even tools that you can read and analyze that information, but that's just for one router or one link. It becomes real hard when you have these huge sets of data, and that's what tools, Carrot and Wandle help with, is taking all that data, crunching it to something so it's useful. Because ultimately,
I mean, we don't like it, but all, I mean, if we all had our way, if we had unlimited budgets, we could make perfect, beautiful networks, you know, that ran great, but we don't have that. And so that's when the business decisions have to be made.
Sure.
You know, and doing that planning cycle and saying, can we get enough information to make good decisions so that they're efficient use of what money we do get.
Wonderful. So is there any other questions from the audience? So I just wanted to switch gears and have a couple of questions as we conclude the session, which is more about sort of new services. So one of the things that one has been thinking about, there's an influx of, let's say, IPTV and video and so on. So how is that, if at all, you know, impacting the capacity planning process? How are the operators looking at it? Or what, in your view, you know, the operators are doing about these new services would be useful to hear about?
I think, you know, the IPTV and video on the internet is that explosive area. Like Duke said, we also don't differentiate a whole lot. We try and capture what's going to explode, but then we try and carry every packet and don't do a lot of differentiation. But I think really the important thing to get right with video is this component of local delivery. And there's the aspect of, you know, if something's delivered locally and it's exploding, then it doesn't necessarily hit your traffic on the backbone and it doesn't necessarily hit your forecast. So you have to get a real good sense of what might fail in that local area and create all of a sudden a very large demand across the backbone. So that's some of the areas that I think the future will require of us to look at quite a bit closer.
Any thoughts from you all?
Yeah, from the vendors, the modeling vendors' perspective, the one side is technology that we need to be able to model multicast. And then for practical purpose, if you already have some kind of multicast going, then we need to able to reverse engineer from the network what's out there. So you issue a show command like show M routes, and we will reverse engineer all those routing tables and then reconstruct the entire spanning tree for you. So that's the technology side. And also implementation side, if you have layer 2 point-to multi-point traffic engineering, then how do you configure the multicast tree? And the other thing is how do you configure a diverse multicast tree so that every receiver will always receive a copy of the movie or TV at any time during any single outage. How do you issue those computation? These are the things addressed by the tool vendor. And on the capacity planning side, it's all about capacity. So on the tree side, the tree has a constant capacity, the bandwidth consumption, but if it's unicast, then it's just tons of capacity. So you need to be able to cater to those modeling to see if you can handle those capacities. I understand lately that level 3's traffic is, the #1 traffic seems to be the Netflix movies. Yes. And they're already exceeding the #2, which is the FTP. So the movie content sending through level 3 will make level 3 the #1 movie, the transporter. But then level 3 may run into some capacity problem, then they can overflow to Amazon, this kind of thing. But all these are interesting, the dynamics in the marketplace.
Cool. Any thoughts?
So interesting you asked about new services. Again, going back to the difference between the backbone operations versus edge operations, I think it's actually a good thing that backbone folks are service agnostic. It means that, you know, they build a solid backbone across which many services can be created and delivered quickly without requiring changes to the backbone. It's already difficult enough to create the service on the edge and all the customer-facing part of it. The role of the backbone is to be able to provide the services that are currently there and in the future. What we find most challenging about the new service creation for networks who are doing their backbone correctly is in the edge, in the regional networks. And that's where the challenges turn out to be different. The challenge in the core is how to do good analysis, how to do good what-ifs, how to do good optimization. The challenge in the edge, again, has to do with automation. You can have very smart people like Duke and Tom who spend their time on a very expensive backbone infrastructure, but if you have 100 metros, 50 metros, or 500 in some cases, where those services start and end, that capacity planning and those operational elements really have to be automated. And that's really, again, where we see ourselves playing, both with a GUI for folks who are doing the analysis themselves, and on the edge for those who really need this work to be automated.
Excellent. Building on that, there's tremendous pressures coming, right? Because you have everyone wanting to do content everywhere, right? I mean, that's the big push from content delivery, people, and even network people, is content everywhere. So you can watch your TV shows on your laptop, on your cell phone, wherever, whenever, right? So, so we crucified Sprint Guy just the other day, right? Because so you have two pressures. You have marketing from people like my company that are saying, yeah, bring it on. We want you to have content everywhere. But then you have, so that's the marketing. We're selling that, right? And then the pressure, though, is building out the network, building out the spectrum,
Sure.
right, to handle all that. And Mom's right. I mean, I think the backbone, we'll be able to adjust and handle it. It's the access that's really going to have the issues, and capacity planning that access is going to be very difficult. I mean, and once again, from us network guys, we say, well, yeah, just put a bigger link in. What's the problem? And then you can't get funding for that. And so that's the two pressures that are coming, and it's going to be a whirlwind pressure. It's going to hit pretty hard. Between the need for content everywhere versus the cost of delivering that, but then wanting to sell it too.
Absolutely. No, and I think the good point was made was that in the access you have to worry about the automation and can you automate fast enough. In the core you're more worried about just looking at it from a capacity planning perspective and a long-term perspective. And the access is also changing very fast. So in closing, I'd like to ask all the panelists, coming of course from the operator side, what is on your wish list? You've talked a lot about how you're using the tools and what they can do, but there's a lot, as we said, there are a lot of developments that are coming down the pike, both in terms of technologies and services. So what might you shed light on in terms of what's on your wish list that you might want to see in the tools going forward, in the near term and the medium term?
I think I've mentioned this before, but we need to get a better understanding for inter-AS type traffic flows. For example, when a failure happens within your network, there's BGP next hop changes that happen, and there needs to be some development work in understanding that traffic that you detect and measure on an LSP basis now will shift to some new pattern. And that involves knowing what traffic flow is coming in from different ASs or going to different ASs.
Any other thoughts in closing?
If wish list,
Yeah, sure.
I'll go big. I'll go big because it would require IETF and IEEE standards, network discovery. So have a tool that you can just turn it on, and it's going to discover your network from layer 1 through layer 3 of the network. So you have both your transport layer and your data layer. You can load them all. Just discovers it all.
Sure.
Now, obviously, you can't do that today because every vendor does things differently. They don't interop. But have IETF standard, IEEE standards that you can interop. You can take this tool, and with this one tool, you can not only run your NOC through it to monitor the network and know that this data router is plugged into this transmission port, and you can see all that. But then through that same tool, then you can run your NOC. You can also run your capacity planning, like what I do,
Sure.
with modeling and so forth. And then getting data, mining data, which Tom and I struggle with that probably, how to get our data. I mean, that's why we even have tools in Carradine and Wandle. Then all that can be all put into one, and you have real-time data when you need it, where you need it.
Yeah, I mean,
That'd be a big wish list.
multi-layer discovery is obviously important. I mean, given there's again, I mean, we had this 10 years back, but now again, there's focus on packet optical and IP optical and integrating the two. And the large operators, and I'm sure many of the medium operators also are looking at how do you do multi-layer network management, and clearly tools that will allow you to do that, as you mentioned. I mean, of course, you went to a full sort of multi-layer discovery, but even if you can do it at 2 layers, you get much more insight into the network. So,
I'll be brief. I second Tom's. Right now we do the L1 discovery and it's painful.
Yeah.
TL1, all sorts of commands, and then patching it together to make the layer 1 segment of the plan files is painful, and that would help a lot.
all right, so any other thoughts from the audience before we close the session out? This is your last opportunity to ask something. Of course, the panelists are there, so you can always talk to them after the panel itself. Going once?
Well, I can answer some of the wish list from Duke. Actually, on the discovery front, layer 3 is easy because you have OSPF, you have NPRS. They are all quite easy. For example, if you have NPRS, all you need in a Juniper router is say show TED database extensive. Then the entire NPRS topology is discovered. But on the layer 2 side, it's already a little bit frustrating because the Cisco has CDP, and the rest of the world, I think with the exception of the extreme using EDP, everybody else is pretty much LLDP. So we have already get into this territory using all this discovery protocol and collect all the information about the spanning tree and do an entire layer 2 discovery. So those capabilities are already in place. And then on the optical side, most of the optical vendors, they are not interoperate at all. So on the other hand, there's an interesting phenomenon in the optical network. Almost every optical vendor has their own tool. Like Cisco 15454 has their Cisco planning tool. And then I guess Sienna has Sienna Core Director, some planning tool. Fujitsu has planning tool. All the optical vendors, they all come the Infinera, I think that's the next talk, they have a planning tool. So all this planning tool actually can discover their network. So one of the things that we're looking for is more integration with the network design tool vendors, meaning that if the optical tool can export some information which is relatively generic, for example, if a lot of 10 gig circuits is carried by Sienna's, I'm sorry, by the Infinera's the planning tool, then the planning tool definitely knows that if you cut a fiber, this bunch of links, this bunch of circuits will be cut together. Then if those information can be exported to Wando or to Carridon, then the SRLG file is automatic. Other than that, so I'm looking for more and more integration between all kinds of the different planning tools from optical side to the IP or layer 2 or layer 3 planning tools. Thank you.
Okay. Well, great. If there's no other questions from the audience, I'd like to thank all our panelists, Tom, Duke, Arman, Dave. Thank you very much, and thanks again to Phil and Tim for organizing this, and Nina. And thanks for all of you for all the interaction, and thank you so much.